Dolby audio coder. So Dolby audio coder and MPG audio coder, two things will be considered here. Uh, Dolby audio coders, in the sense it is also similar to the MPG audio coders. It is a kind of MPG audio coder. Here the psychotrust model, that means psychoacoustic model, is which is associated with the MPG coder, which will control the quantization accuracy of each subband sample by computing and allocating the number of bits to be used in the quantize of the each sample. The quantization accuracy used for each sample in a subband may be vary from one set of subband samples to the next. The bit allocation information, which is used to quantize the samples in each subband, sent with actual quantized samples. So everything will be done by the decoder or dequantizer of the subband samples. The mode of operation of the perceptual coder is also known. It is called as forward adaptive bit allocation mode. So here the advantage of this MPEG coder is psychoacoustic model is required in the encoder, and disadvantage of this kind of MPEG coder is significant portion of the each encoded frame contains bit allocation, which is relevant and inefficient, that is available bit rates. Variation of this approach to use the fixed bit allocation strategy for each subband, which is then used by both the encoder and decoder. So here typically the bit allocations are selected for each subband are determined by known sensitivity characteristics of the ear and use the fixed allocation, that means this information cannot be sent in the frame. This approach is used in a standard known as a Dolby AC1, that is AC indicates the acoustic order. A Dolby AC was designed for use in satellites to relay the FM radio programs and sound associated with the television programs. It uses the low complexity psychoacoustic model with the 40 subbands at sampling rate of 32 ksp's, proportionate to 44.1 and 48 kilo samples per second. Second variation, which allows the bit allocation per subband to the adaptive while at the same time minimizing the overhead in the encoder bit stream. So for the decoder also contain the copy of psychoacoustic model. The decoder is used to compute the same or very similar bit allocations that the psychoacoustic model in the encoder is used to quantize each subband samples. In order for the psychoacoustic model in the decoder, which is used to carry the own computation bit allocation. So this operational mode is, instead of each frame containing bit allocation information, in addition to the set of quantized samples, it contains encoded frequency coefficient that are present in the sampled waveform segment. So this is nothing but one kind of Dolby AC2 acoustic coder. So here the standards are utilized with the AFB, QB and FF, that is subband sampling, quantized subband samples and bit allocations, FF, which will be given to the destination demultiplexing, and DQ and SFP. Advantage of this model is it can produce the high quality, high fidelity signals. Disadvantage is for the broadcasting purpose, the psychoacoustic model is required in the decoder. So to meet the above requirement, the third variation has been developed in both backward forward principles. So adaptive methods are used in this one. So psychoacoustic model used the encoded spectral envelope. The quantization accuracy of the subband is samples are affected by the quantization noise introduced by the spectral encoder. In case of hybrid scheme, although the backward adaptive bit allocation is used using the that PMB, that is we call it as psychoacoustic model. AFB is nothing but the analysis filter bank. So if you see here, AFB is nothing but analysis filter bank, SFP is nothing but synthesis filter bank, and PMF is a psychoacoustic model, FF is a frame formatter, DQ is a dequantization block, QB is the quantization block, spectral envelope decoder and encoder. So this is encoder and this is decoder. So in this hybrid model, the backward adaptive bit allocation is used in AC2 using PMB. An additional psychoacoustic model PMF is used to compute the difference between the bit allocation computed by the PMB. The above information is then used by the PMB to improve the quantization accuracy. The modification information is also sent in the encoded frame and used by the PMB. In addition that it should be required to modify the operational parameters, that PMB and encoder and decoder, then the information will be passed with the computer difference information. So PMF must compute the two sets of quantization information for each subband samples. Then the decoder may consider for the detection of this thing. The decoder will consider for the detection of this thing. This hybrid approach used in the Dolby AC3 standard, which has been defined for use of similar range of the applications. For example, high definition television standard use this acoustic quality of the MPEG and Dolby audio coders. Comparably, they are using that one. So in order to obtain the continuity from one block to the next, 256 subband samples in this previous blocks are repeated to become the first 256 blocks in each contains the 256 samples. So assuming that the PCM sample write is 32 kbps, although each block sample is 8 millisecond duration, the 256 by 32, the duration of the each encoder block is 16 milliseconds. The audio signal bandwidth at this sampling rate is 15 kilohertz, and each subband, the bandwidth is 62.5 hertz, that is 15k by 256. The stereo bitrate is typically 192 kilo samples per second. So here if you talk about the MPG coder, the bitrate is monophonic, dual phonic and two channel and single channel. So the bandwidth required for audio may be based upon the monophonic or dual phonic, or it may be a stereophonic, or it may be two channel stereo. So all three layers are increasing the level of complexity to achieve the particular perceived quality. Choice of the layer and bitrate is often compromise between the desired perceived quality and available bitrate. So if application is digital audio cassette, in the sense the compressed bit is 448 kbps, the quality is 192 kbps per channel, and sample delay is 20 milliseconds. If it is digital audio and video broadcasting, in the sense the compressed rate is 192 kbps and quality is 128 kbps per channel and 40 milliseconds for the delay. And CD quality for low bitrate channel, in the sense this is 65 kbps, 64 kbps is the quality, and 60 milliseconds for the operations. These three layers are formed: layer 1, layer 2 and layer 3. So layer 1 is the basic mode, other two are increasing level, in turn produce the level of compression for the same perceived audio quality. So layer 1 does not include temporal masking, but it present in the layer 2 and 3. The format of each layer is similar to the first layer, and each frame contains 384 samples, and time duration is equal to 1152 samples.